visual is because there was one like this on the homework, and I saw a lot of people not do it. So I was thinking maybe a visual would help you see it, but some of you are able to see it without the paper. So if I said to you, okay, well, here's our flat box here. We don't know this side length. We're going to call it X, 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 X. So then I want you to fold it up, each piece, and make an open box here. So we did that. And then write a statement for volume. So everybody, you took 21, and then you folded up the flap and folded up the flap. So you took off how many X's? I saw that you guys did that right. So you said the volume is, well, the length, or the width, you said was, sorry, I'm doing it in blue, but it's fine, it's red. So you said it was 21 minus 2 X's? I saw all of you do that out there. Okay, good? What was the length? 28, pulled up, so you're right. 28 minus 2 X's. And then here's where we have a little air somebody out there, a few people out there. Our height is just what? Our height is just up X, So good. Our volume, our statement for volume would have been 21 minus 2X, length times width times height. 28 minus 2X. And then I always put X in front. Guys, if on the test, if I want you to put it in standard form, I'll say, write the statement for volume in standard form. If not, you can just stop here. If you went extra far, that's okay. Standard form is not any better than factored form and vice versa, but you just did extra work. Okay, good. So, awesome. Way to go. That's just a statement for volume. Now, let's say I said to you, find the max volume. How would we do that? Yeah, we would graph it, and it would have some, then we would find the maximum, right, everybody? Yeah. That would represent the max volume. Okay, good. Let's get to today's lesson. So we're going to get right into it. All of my examples are coming off your homework today. Then also, I need you to have blank paper out because the back is very squishy and your work cannot be squished. Okay, so focus while you get your notebook out. We want to go, go, go. So, we are learning today just a bunch of different ways to factor so that we can then solve easily. So we know that if we are asked to solve, we try to solve by factoring. So we actually already know how to do some of these methods that we're learning today. So we're just getting really good at it. So if I said to you, find all the solutions, you would say, I need to see if this factors. Well, what type of factoring is this? There's 1, 2, 3, 4 terms. So I should try factoring by grouping, right? Okay, let's do it. And then if it doesn't factor by grouping, we would have to solve by a different method of factoring, which we haven't learned that yet. So pull out a what? 5v squared. Good. So then divide by 5v squared. Divide by 5v squared. So then left would be 8v minus 5. I need to use my microphone. Then right here, what are we going to pull out? Good. You said negative because of the front thing. Way to remember. Pull out negative 2. Divide by negative 2. Divide by negative 2. Left is 8v minus 5. Now everybody understand. If you were to get to this point and inside wasn't the same, you'd have to just stop, erase it, and you'd have to solve by a different method because it doesn't factor. That's not going to happen on this test. If it factors by grouping, it's going to work. So here we go. Pull out an 8v minus 5. There's only one of them. We factored it out, so it divides out, and then left is 5v squared minus 2. Now, all we've done is factor it. This one said find the solutions. We're using factoring to solve. Well, now that we've factored it, can't we set each of our factors equal to 0 and solve? So 8v minus 5 equals 0, and 5v squared minus 2 equals 0. Solve for v. So we would do what here? Add 5, divide by 8, right? So v is equal to 5 divided by 8. There's one of our solutions. Over here, we could see if it factors. It doesn't, but we wouldn't solve with that method anyways, because what would we do? We'd just get v alone. So we'd add 2, divide by 5. So we have v squared equals 2 divided by 5. That's why we spent a whole day doing this last time, so that when we get to this step, we don't make errors. Square root, root cancels out with power. V is equal to plus and minus. When we have a fraction and radicals, what do? Yes, but our first step is to split it up, right? Yes. Square root of 2 over the square root of 5. And then you're saying that we can't have a radical on bottom, so yes. We would multiply by root 5 root 5. So now our final answers are v is equal to plus and minus. We have a root 10 on top, which nothing pulls out. And then divided by root 25, which is 5. Don't be the person, I've seen it already today in first hour. People say the bottom cancels out. No, it doesn't just cancel out. It becomes a 5. Do you guys see?
Yes.
Okay. Now check. All of our solutions when we get to our test should match up with our degree. We have 1, 2, 3 solutions. Was it degree 3? Yes. So I'm not missing anything. You should be checking that every time. Next one. Actually, that's all you need to see. So now I'm going to give you about 10-ish minutes to work on the front. So you're solving by factoring. So you're going to look, is there a greatest common factor? If not, is it factoring by grouping? If not, is it a quadratic? Check every time. The degree should match up with the number of solutions. And go. So we're now going to remember, we did learn this the first day, but we're going to learn how to factor by factoring those that are quadratic in form, and then we can then solve it. So quadratic in form, just remember, it looks like this. It has x to the 4th, then it jumps down x squared, then it has a constant. That looks so close to this, x squared minus x minus 2, right, everybody? Except for it's 4 to constant. It's quadratic in, quote, form. So remember we did a u substitution. We said, well, we can write this all in terms of x squared and then insert a u. So x to the 4th is x squared squared, so then we have minus x squared minus 2. So we said let u equal x squared, or let x squared equal u, and then we inserted and put a u wherever there was an x squared. That gave me u squared minus u minus 2, and now we could factor the u part. So we would do what multiplies to be negative 2 and adds up to be negative 1. 1 times 2, negative 2. We can quick factor. So this factors to be u plus 1, u minus 2. And then we'd say, but we're not actually dealing with u's. It's actually x squared plus 1 times x squared minus 2, correct? And then we can set each of those equal to 0 and solve. Okay. Yes. I think I just made this problem up. I don't know if you're, are you relating to this one based on the homework?
No.
Oh.
I'm saying that the 1 is going to be squared. It's not negative, but is there table over that?
Oh, well, it needs right here. It needs to add up to be negative 1. You're okay. You're okay. It's a valid question. Okay, awesome. Let's do number 9 then. So you look at it. I'm not going to say do a u substitution. I'm going to say solve, period. There's going to be a big section. You're going to have to look at this one and go, you know what, that looks quadratic in form. So let's do a u substitution. Let u be x squared. So then right here we actually have x squared squared minus 5x squared plus 4 equals 0. So inserting your u. U squared minus 5u plus 4 equals 0. Now we can factor it easily. Well, multiplies to be 4 and adds up to be negative 5. 1 times 4, and it looks like both of them need to be negative. True? So it works in both boxes, and then we can quick factor. You always do want to check that. So u minus 1 times u minus 4. Then we would insert our x squared back in, so we're dealing with x squared minus 1 times x squared minus 4. Now we could keep factoring these possibly, but let's just solve these since it does say solve. Let's just solve these using the most appropriate method. So let's set each of them equal to 0. X squared minus 1 equals 0. And we also have x squared minus 4 equals 0. So now look, can't we just solve for x? So we would, don't just square root it. Guys, this is why we went over this last time. Add 1, x squared equals 1. Then we would square root. So x is equal to? Good, plus and minus 1. There's 2 answers right there. So we would add 4, so x squared equals 4. Then we would square root, so x is equal to plus and minus 2. Now check. We have 4 solutions. Was the original a degree 4? Yes, so we're not missing anything. You always should do that, every problem. Next one. Let's do 11. Same thing. You'd say it's degree 4, 2, and then constant. It's quadratic in form. U squared minus 10u plus 16. So you guys tell me what the factors are. H times 2, negative, negative. I can quick factor. Okay, good. So you guys continue finishing this one on your own. I know you can like still see it. It's like projecting on me. It doesn't do anything. Check your answers when you're done, but don't look up here until you've done it. Count 4 solutions. It was degree 4. We're all good here. Okay, look at number 27 with me. There's the easy way to do this one, and then there's the hard way. So once again, you would recognize degree 4, 2, constant. It's a u substitution. So 2u squared minus 26u's minus 28 equals 0. Now we could factor this, but that would be long factoring. So let's be smart about from now on, we're just going to remember that our first thing we should always do with everything is factor out the greatest common factor. So let's pull out a 2. So then divide by 2. So then left would be u squared minus 13u's minus 14. Now guys, will this 2 affect my solutions? No, can't I? If I was factoring, I need to leave it, right? Yeah. But I'm not factoring, I'm solving by factoring, so couldn't I just divide out the 2 right here, right now? Okay, then we're just looking at u squared minus 13u minus 14. There wasn't a variable with the 2, therefore it doesn't matter. When solving, that is, when solving. Okay, so now 1 multiplies to be negative 14, adds up to be negative 13. Now we get a quick factor. If we would have long factored, that would have been a lot of extra work. So you guys go ahead and finish that one off. Checking your answers when you're done. 4 solutions. It was degree 4, so we're not missing anything. Number 29, any suggestions of how to solve it? Should I add 81 and then 4th root it? No, do not do it. You're going to be missing a lot of solutions if you do that. You know, I can't tell you how many people do that on a test. Wrong. What should we do? Yeah. Yes, you're both saying that exact same thing. Perfect. So tell me how you would write it. How you would write it. Okay. Okay. Good. Uh-huh.
Plus or minus 3, each 3 has a multiplicity of 2.
Hearing lots of good things. Anyone else have an idea? Yeah, that's maybe a really good idea. Maybe we should split this up. So just so we don't get confused, because we're having some correct answers here, but we're kind of, if we don't split it up, it can be confusing. So we really have x squared equals 9, and we really have x squared equals negative 9. Agreed? So now solve them separately. So now we have x is equal to plus and minus 3, but this isn't going to be the same. So square root x is equal to plus or minus 3i. Awesome. You guys all were thinking awesome out there. Very good. Okay, awesome. So there's our 4 solutions. So yeah, you would want to split them up. Okay, good. Thank you for participating, everyone. Okay, what I'm going to do now is give you some time to do these ones. Ready, go. Don't do ones that are not assigned. There's a reason I'm assigning these ones right now. Okay, so now we're going to learn how to factor 2 perfect cubes. So we know how to factor 2 perfect squares. Look, perfect squares meaning if I take the square root of that, I get x, right? Square root of that, I get 3. And then wouldn't this factor to be x plus 3, x minus 3? Yes. That's factoring 2 perfect squares. It's way different when factoring 2 perfect cubes, so degree 3. So write this down, then I'm going to teach you how to memorize it in a way, a little trick. So a cubed plus b cubed, if you have something of this form, it will factor to be this. A plus b, parentheses, times by a squared minus ab plus b squared. That'll be factoring it, and then once we've factored it to that point, it'll be easy to solve. So if it's subtraction, two perfect cubes, the difference of two perfect cubes, it'll factor to be a minus b times a squared plus ab plus b squared. Write both of those down, and then I'm going to make sense of it, or like teach you a trick to memorize it. This is going to work. Okay. So this is kind of a trick. So if we cube root this, it's just a. If I cube root that, I just get a. Correct. If I cube root this back thing, not including the sign, just like we didn't do the sign here, if I cube root the back thing, I get b. So this is what I'm going to call the front. This is what I'm going to call the back, which makes sense. So now look what I do. Our first factors, we literally just take and insert those right in. And then the sign is the same as the original. Do you see? Okay, so then the next thing, the next factor here is when the little saying begins. A little song, I guess you could say. So it goes like this. You take the front times the front, then the front times the back, then the back times the back. So one more time. So you take the front times the front, which a times a is a squared. Then you take the front times the back, ab, not including the sign, not including the sign. Then the back times the back, b times b is b squared. So then this is how the signs will always work. The first sign will be the same as the original. The next sign will always be opposite of that. So if this was plus, this is negative. And the last sign is always, always positive. Always going to work that way. So look, it really does work that way. Look, if I take the cube root of this, I get a, I get b. Do you guys see? Yeah. Then I go like this. I put the sign in the same. Then not including the sign though. Do not look at the sign. Did you all hear that? Yeah. So you do the front times the front. A squared. Then the front times the back. AB. Then the back times the back. B squared. And then this sign and this sign are opposites. And then the last sign is always positive. It always works that way. So here we go. Let's put it into action. So number one, we have 8x cubed minus 27. You would say, oh, it says find the real or imaginary solutions. It's so tragic on the test when I see someone add 27, divide by 8, and cube root it. No. How many solutions should there be? 3. We don't do plus and minuses and stuff with cubes. So we have to factor this. You'd say, oh, it's two perfect cubes. Cube root the front thing, cube root the back thing. So our front thing is 2x, right? So the cube root of 8, what times what equals 8? 2 times 2 times 2. And then x cubed, cube root is x. Cube root of 27, 3 times 3 times 3, so that would be 3. So now we'll do our little parentheses. Oh, I spread that out way too much. Okay, let's do our parentheses. Put in the 2x, put in the 3.
And then the sign carries over.
Yep, the sign carries over. Now right here, we'll do the front times the front.
4x.
Yep, 4x squared. Then the front times the back. 6x, yep. Then the back times the back. 9. Then this sign and this sign are opposites. The last sign is always, always positive. We just factored it. That's factored.
And that's all we have to do.
Yep, that's factored, and now we'll use that to solve. Because we know how to solve linear, and we know how to solve quadratics. Now, fun fact for you. So if we have something linear, and we have something quadratic. We could see if the quadratic factors will multiply to be 36 and adds up to be 6, 9 times 4, 1 times 36, 6 times 6. So nothing. Fun fact, if you're doing two perfect cubes and you factor it down to this, the quadratic part will never, ever, ever factor ever. Now here is why. If you were to graph this, everybody, if you ever graph two perfect cubes, it'll look like something like, it'll only cross the x-axis in one spot. So doesn't that mean there's only one real solution? There's 3 solutions total, right? Yeah. It only crosses one time, so there's only one real solution. So the quadratic part is where the imaginary solutions come from. The 2 imaginary solutions. That always happens if you graph 2 perfect cubes. Okay, so let's solve this one. 2x minus 3 equals 0. We have 4x squared plus 6x plus 9 equals 0. Solve for x. So right here we're going to get x equals 3 over 2. There's our real solution. That's where it would cross the x-axis. Great. Now right here it's not going to factor, so we have to use quadratic formula. That's why we spent all the time last time making sure we could do that right. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. 2 times 4 is 8. Then remember, our next step is to then type that into your calculator and tell me what's under the square root. I know, you have the worst seat in the house. I tried to get you to move.
I know.
I'm sorry. Okay, that's fine. I'm just saying, I'm sorry. I'm just saying it's my fault. Okay. What's under the square root? Well, you would have been forbidden to that back corner very strong. Thank you. Negative 108. Then we're off to the side and we say, okay, now I got to break down the square root of negative 108. So we're going to break it down. Give me some factors of 108.
4 and 27.
Okay. 4 times 27. I actually like that one. Then 2 times 2, and then 27 is 9 and 3. And then 9 breaks down into 3 times 3. Watch what I do so I don't double dip. Cross out things that I've rewritten as something else. Okay, cool. Point out groups of 2. Pull out a 2, pull out a 3, pull out a 9, right? Yeah. So that would be 6i, everyone. Left would be a 3. So we have so far x is equal to negative 6 plus or minus 6i root 3 all over 8. Then you'd say, if all 3 things divide by something in common, I can divide it out. We all divide by 2. This becomes a 4, a 3, and a 3. So put all your answers in the same spot. So x is equal to 3 halves, and x is equal to negative 3 plus or minus 3i root 3s all over 8.
No, 4.
Right. No, it's fine. All over 4. So then you would check. It has 1, 2, 3 solutions. Was it degree 3? Yes. So we've got them all. So if these won't ever factor, won't I always need a quadratic formula for that? And I told you that they'd always be imaginary. That's always going to happen. Do another one for practice. Here we go. This one's going to go quicker though. So cube root the front thing, you get x. Cube root the back thing, you get 4. Let's go ahead and start factoring this bad boy. Front times the front. Front times the back. Back times the back. Okay, good. This sign and this sign are the same. The next sign is opposite. The last sign is always plus. We just factored that so quick. Okay, awesome. Let's solve this. So we have x plus 4 equals 0. X squared minus 4x plus 16 equals 0. So x equals negative 4. There's one of our solutions. The one place it does cross the x-axis. And then we're going to need the quadratic formula for that bad boy. Ready, set, you go. Oh, this one throws people for a loop. Let's look at number 3. Here's what you're forgetting. If you take, well, first of all, they'll say, oh, I'm going to take the cube root, but then those aren't perfect cubes. Now, here's the one thing you guys have got to remember with all factoring. Before you try any factoring method, you need to be factoring out greatest common factors every time. So what should I factor out from the get-go? 2. So then divide by 2, divide by 2. Now left is x cubed plus 27. So now, there we go. Now we have 2 perfect cubes. Good, yep. So we have x, the cube root of x cubed is x, the cube root of 27 is 3. Can we do it quick now? Front times the front, front times the back times the back. This sign and this sign are the same. The next sign's opposite. This sign's always plus, and then the 2's in front. Now question, is the 2 going to have an effect on my solutions? No, you're right. Why not? Because what 2 equals 0, do you see how there's not a variable? Couldn't I just divide out 2 right here, just like with the quadratics we talked about? Yes. So this is factored. You need it. If I said factor, you would need it. But to solve, we could just divide out the 2 right here, right now, and now we're not even worrying about it. 0 divided by 2 is 0. So we're going to get x equals negative 3, and x is equal to quadratic formula. You guys go. Ready, go, go, go. Everybody, this one, I don't know why. It throws people for a loop. Oh, I need to unfreeze that real fast. Okay, so people, I don't know why people freak out. Is this 2 perfect cubes?
Yes.
Yes. What's the cube root of 27? What's the cube root of x cubed? What's the cube root of 1? 1. So it is a perfect cube. Front times the front, 9x squared. Front times the back, 3x. Back times the back is 1. This side and this side are the same. The next side's opposite. The next side's plus. And now we can solve. Don't freak out. Just because something's a little different. Okay, awesome. Go for it. On how to do 25. Yeah.
Wait, it never
Factor out x first,
Okay.
and then it's a perfect cube.
Awesome. Factor out x and then it's a perfect cube. Guess what I had somebody do first hour, which was a good lesson learner, because now she'll never make that mistake again. She went, oh. It doesn't become a 0, it becomes a 1. That's what she did. Okay, cool. So now remember, this should have 4 solutions. So right here is going to have a solution, right?
It's going to be 0.
X equals 0 is a solution from that, and then we'll factor that bad boy. Then you're going to need the quadratic formula for that. Once again, degree 4 should have 4 solutions. So, this is just a little picture to show you everything. This is all we've learned. If I say to you, because there will be a section on the test where I literally just say, solve. And it's going to be, it's not going to give you any hints. It's going to be all these different types of problems all mixed together at all different difficulty levels. You as a student have to be able to look at a problem and say, okay, I'm going to try factoring by this method because of what it looks like. Does that make sense? So, these are the different methods so far if you want to take a picture of this. Greatest common factor is the first thing you check for. Then we know how to solve quadratics. Today we went over solving by grouping. If there's 4 terms, quadratic in form will look like that. 4 to constant or some form of that. And then the sum or difference of 2 perfect cubes.
Don't do 17 through 22.
We'll talk about that. If you're the volume of an object is 84 cubic feet. The feet cubed part is just the unit of measurement. Our width is x, our length is x plus 1, and our height is x minus 4. It wants to know what is the width, what is the length, what is the height. Well, we need to know x to know that. True? So guys, if you're ever solving an equation and you just set up a true statement and you have an unknown, set up a true statement and then solve. So what's our true statement? Volume equals length times width times height. So we'll plug in what you know. 84 is equal to our length, x plus 1, times our width, I'm going to put the x in front, times our height, x minus 4. Now think about it. We want to know what x value will make this a true statement, correct? So we could solve, we're not going to want to do guess and check because it might work for this one, but on the test, what if it's a decimal? So instead, you want to solve by calculator. You don't need to multiply it out, leave it. Guys, think about it. If we were to graph a straight line at 84, and we were to graph this cubic, it's like degree 3, we graph it, let's say it looks like this. Isn't this function, isn't that where it right there is where it's 84, true?
Yeah.
So you want to go and find the x that makes it up at 84. So then you'll do second trace, and you'll find the intersection. So everybody, go to y equals. In y1, type in 84. Then that's going to be a straight line at 84. In y2, type that in. You don't need to multiply it out. Then hit graph. Now think about it. Your window would need to be at least as high up. We have it as high up as 84. So you go to y max and make it maybe something larger, like 90. You don't need to change everything equally. You know that, right? Just change y max to 90. Now you do have to be able to visibly see with your eyeballs where the intersection point is. If not, you might need to change your x-axis further out.
So is y max you change?
Yeah, because that would be as high up. Y max is as high up because that's the y-axis. So I changed it to something larger than 84, maybe 90 or so. Then hit graph. Now we want to know where they intersect. So do second trace, intersection. Then it's going to say first curve. That just means what's the first equation? Hit enter. It's already on the right spot. Second curve. It's already on the second equation. Then it says, do you want me to guess where they intersect? Hit enter. Yes. So you said that they intersect at x equals 6. Yes, that is true. Hopefully you all got 6. You have to be able to do that with your calculator on the test. So 6 is your, what? And what's the other measurement? 7? And your other one is 2. It asks what are the measurements. Do you guys understand that? 6, 7, and 2. If x is 6.
I get it.
Okay. All right. Now, what if I would have asked you find the maximum volume? Well, 84 is not the max necessarily, right? Not necessarily. So if I said find the max volume, don't you find the maximum?
Yeah.
Okay, awesome. Just making sure. Which, that wasn't the best problem to ask you to find the maximum necessarily. Okay, let's read this one, guys. It says the product of consecutive integers are whole numbers, n minus 1, n, and n plus 1 is equal to negative 336. What are the integers? I want to tell you what consecutive means. I always see one like this on the ACT often. So guys, here's an example of consecutive. Consecutive means one right after another. 1, 2, 3 are consecutive numbers. Negative 8, negative 7, negative 6 are consecutive numbers. One right after another. So it says the product, that means multiplication of 3 consecutive integers. It even tells you n, n minus 1, and n plus 1. You see how those would be consecutive? Okay. So then you'd say, okay, the product of n, n minus 1, and n plus 1 equals what? Negative 336. And then are we just solving for n? So we'll solve by graphing. Type this into y1 or y2. It doesn't matter. Type this into y1 or y2. Graph it. Now think. You're going to have a line at negative 336. So you're going to have to go to y min and at least change it to negative, I don't know, 340 or something. And then make sure you can visibly see with your eyeballs where it's crossing. Oh, it was crossing the negative, I think, actually. Okay. So then do second trace intersection. I will give you the n that makes it a true statement. Not second trace. Second trace intersection, right? So now you should be able to finish the worksheet.